We're going to continue talking about graphing sine and cosine, and we're going to have different periods today. So let me grab these other pens over here. Trying to not just throw away pens when they're like half good. So, but if they get bad, I will start to throw them away. So let's talk about changing the period. Okay, so here's what we've got. So for y equal to sine of x, this pen is my trash. Sorry, this is the usual testing of pens to see if anything's good. Y sine of x, or y equal to cosine of x, and you're also trash. The period of these functions is 2 pi. Unless we alter it somehow. That makes sense in some way because you're essentially thinking about going through a full revolution of the circle to go through all the values, right? If we think about it, this is 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and then back to 2 pi radians. If we're going to graph sine, for example, done as well. So I was graphing y equal to sine of x, where again we know that this point is the point 1, 0. This is the point 0, 1. This is the point negative 1, 0. This is the point 0, negative 1. The usual values we graph for sine are cut this in half, cut it in half again and again. Right, sine starts at 0 and then goes high to pi over 2, it's equal to 1, and then back to 0 at pi, and then down to negative 1 at 3 pi over 2, and then back to 0 at 2 pi. And then we just keep doing the same thing over and over and over again, right? I did one full revolution, and now I can keep going, right? You can say, well, if I go another pi over 2 to 5 pi over 2, I'm going to be back at 1. And then I go even further to 3 pi, and I'm back at 0. And then down to 7 pi over 2, I'm back at negative 1. And all the way around the second full revolution to 4 pi, I'm back at 0. So once you've gone one whole time around the circle, if you keep going around the circle, you just keep getting the same graph. That's why it's called a period or periodic, because it does the same thing over and over. So this looks like this. Right here's your usual one period of sine, and then it just does the same thing again. And it would do the same thing again, and again, and again, and again. So the usual period for a trigonometric function, sine or cosine, is 2 pi. So this length is 2 pi, this length is 2 pi, and we could have another one that would look the same after 2 pi. And the same is true for cosine. So here's the thing I want you to kind of think about or keep in mind when we're doing this. To get one full period of sine or cosine, we need the angle x, or whatever you want to call it, theta. We need that angle to go from 0 all the way around to 2 pi. That's kind of what we have to have happen to get one full period. So let's look at this next example. Let's say I want to graph y equal to sine of 2x. I will point out that yes, I know we have a trig identity for sine of 2x, where it's equal to 2 times sine of x times cosine of x. That is not a helpful piece of information here. It's still true, but knowing that this is 2 times sine of x times cosine of x would not help us graph it at all. It would make it way more complicated. So here's what we have to keep in mind. Our angle now, we're calling the angle 2x. Our angle or argument, and the argument is the thing that's inside the function, is 2x. And we need our angle to go from 0 to 2 pi. So we need 2x to go from 0 to 2pi. And the way I'm going to write this is we need 2x to go from being bigger than or equal to 0 all the way to being less than or equal to 2pi. It's going to hit all the values in between there, just like, I should point out, for this function, one period, we had x going from 0 to 2pi. Same deal on this other one, except now it's not sine of x, it's sine of 2x. Okay, well now here's the easy part. I'm going to graph, I'm not going to make my x-axis 2x, I'm still going to make my x-axis just the regular x-axis. So I'm still going to graph it like that, where here's my x, here's my y, here's 2pi, there's 1, there's -1. But what I can do to this inequality, this compound inequality, 0 less than or equal to 2x less than or equal to 2pi, is I can divide everything by 2. 0 divided by 2 is 0. 2x divided by 2 is x. 2pi divided by 2 is pi. So check this out. For my angle 2x to go from 0 all the way to 2pi, the variable x, which is what our x-axis is representing, has to go from as low as 0 all the way up to just pi. So we get one full period from 0 to just pi. I know my writing is not great there. So what that means is we're going to get the usual sine graph, but it's going to get smushed, right? Before we get to go all the way from 0 to 2pi to get one full, middle, high, middle, low, middle. But now we're going to get that in half the distance. So there's pi. And then this length is going to be one full usual sine graph's worth of stuff. So I'm going to break 0 to pi up into the usual 4 sections or 5 points. So I'm going to break that in half and then in half again. And I'm going to start middle and then go high and then back to the middle and then go low and then back to the middle. And if you wanted to, you could repeat that again. Middle, and then high, middle, low, middle. So when I graph sine of 2x, I think about it in 2 different ways. You can either think of the period is half of what it would be. It's 2pi divided by 2, which is pi. The other way to think about it is whatever this number here is, you get 2 full periods in the usual period length. So that's what's happening here, is that this coefficient of x is going to change the length of our period to either make it smaller if this number is large, or make it bigger if this number is small. I feel like there was something else I wanted to say there. Yeah. So the last thing I want to say about this particular example is, and so this is something I'm going to say a lot, is typically when you graph a trig function, I know I said this last week, you're going to want to plot or mention somewhere kind of the 5 important points. Not everyone has you do this, but I think it's important, and I'm the one teaching the class, so you get to do it. Right, I want to know what these 1, 2, 3, 4, 5 points are in a period. The beginning, the first quadrant, the second quadrant, the third quadrant, the fourth quadrant. So this is the point. And you can either write them on here, right here. I would probably just label them on the x-axis. I know this is. So I'd say, okay, well, that's obviously the origin. You don't have to label the origin. That's a freebie. But the rest of them, right, that's going to be pi over 4. And that's going to be pi over 2. And that's going to be 3 pi over 4. And that's pi. So it's all the usual points cut in half. Okay. So let's look at some more examples. Actually, before we look at some more examples, let's talk more generally. So here's what we get to say more generally. For y equal to sine of b times x, we use a capital B there, or y equal to cosine of b times x. The period of the function, meaning how long it takes to repeat its shape, is the quantity 2 pi divided by b. This makes perfect sense in the context of what we were just saying, right? If I want my angle to go from 0 to 2 pi, so my angle, which is b times x, needs to go from 0 to 2 pi. So I need 0 to be, I need b times x to be between 0 and 2 pi. And if I divide everything by b, zero divided by anything that's not 0 is still 0. B times x divided by b is just x. And 2 pi divided by b is 2 pi divided by b. So the new interval for one full period is everything from 0 to 2 pi over b, which has a length of 2 pi over b. So that's how, so the shortcut or the fast way of finding the periods would be like, okay, what's multiplying x? 2 pi divided by that is our new period length. And I should ask if there are any questions about that before we do more examples. So hopefully you guys are doing all right. In Woodland, it is really hot. It's like 108 degrees today, I think, or 107. It is stupid outside. Hopefully where you are in the world, it is not as hot as that. All right, so let's look at some more examples. Yeah. So let's look at the example y equal to cosine of 3x, sorry, x over 3 plus 2. Also, my cat has just entered the room because apparently she was scratching at the door. So I might say hi to my cat at some point. She might meow at us. It's all right. A couple things going on here. First of all, we have a vertical shift. That's something to take note of. We do have a vertical shift of plus 2. So we know this whole thing's going to be moved up to our new midline is going to be 2. The other thing is we do have a different period. So what's the coefficient of x here? This is something people sometimes have a hard time with. Here, this is x divided by 3, or I can think of it as 1/3 times x. So you might find yourself wanting to rewrite this as cosine of 1/3 times x plus 2. So that the period is 2 pi divided by the coefficient of x. So that's going to be 2 pi divided by 1/3. When you divide by a fraction, you multiply by its reciprocal. So this is the same as 2 pi times 3 over 1. Or if you prefer, 2 pi over 1 times 3 over 1, which is going to be 6 pi over 1 times 1, which is just 6 pi. So that's our new period. So we're going to have one full period from 0 to 6 pi. And we're going to go up 2. So there's 2. And I forgot to ask, what's our amplitude here?
Repeat just.
Sorry, I didn't hear you. I'm sure you said the right thing. The amplitude is just 1, right? There's a 1 times cosine there. So we're going to go up as high as 3 and as low as 1. Now you might be asking, how am I going to find these important points here? Well, you could divide this in 2 and then divide that in 2 to get that point there. Like, so 6 pi divided by 2 is 3 pi. 3 pi divided by 2 is 3 pi over 2. But then this point here is kind of a pain. And it gets even more painful, I guess is the way to say it, if your numbers are less nice. So here's a way that I typically like to find the 5 important points. And I should say, for us in all of these examples, the first important point or x value is always going to be 0, because we haven't done any horizontal shifting, and we're actually not going to do any horizontal shifting. So our first important x point is x equal to 0. And then here's what I want you to notice. These points are always spaced out the same amount. These points are always 1/4 of a period away from each other. Because 1/4 plus 1/4 plus 1/4 plus 1/4 is 4 quarters, which makes up a whole period. So what I really need to do to find this first point, if I was penny like I didn't know it, is to find out how much 1/4 of a period is. Well, that's not too terrible. My period is 6 pi. 1/4 of my period is 1/4 times 6 pi, which is 1/4 times 6 pi over 1, which is just 6 pi over 4, which reduces to 3 pi over 2. So to find all of my subsequent important points, I'm just going to keep adding 1/4 of a period. So my first point is 0. My second point, I'm going to add 3 pi over 2. 0 plus 3 pi over 2 is 3 pi over 2. For my third point, I'm going to add another 3 pi over 2. And 3 pi over 2 plus 3 pi over 2 is 6 pi over 2, which is 3 pi. And then to get my fourth point, I'm going to add another 3 pi over 2. And here's where it's going to be nice to have not reduced my fraction. So 6 pi over 2 plus 3 pi over 2 is 9 pi over 2. And then finally, to check that my last point is right, I add another 3 pi over 2 to get my fifth point. I know I'm running out of room here. And 9 pi over 2, plus 3 pi over 2. Oh, I forgot to start recording. Or I am already recording. I forgot to stop recording. It'll work out perfectly. I messed up and then I didn't, so it worked out fine. 9 pi over 2 plus 3 pi over 2 is 12 pi over 2, which reduces to 6 pi. So if you do this right and you add 1, 2, 3, 4 quarters of a period, your end value should be whatever your period length is. Great. So, ow, sorry, 1 second. I just stepped on something a little sharp and I don't know what it was. Oh well, I don't see it, so hopefully I don't do it again. Maybe I should put on shoes. Oh well. So I typically want you to tell me what these 1, 2, 3, 4, 5 points are. Really 4 points, because the first one's going to be 0. When you graph a sine or cosine function, I want to see those 5 important points. And then it's cosine. So cosine, we know, starts high, and then goes middle, and then goes low, and then back to the middle, and then back to the top. So there's my cosine of x over 3 plus 2. Now, if you looking at this on the screen, like this one doesn't look as high as that one. Sometimes your graph is not going to look perfect. But if you notice it doesn't look perfect, you can fix it a little bit. That's a little bit better. One more thing I want to say, because this is kind of really important. the reason that these values are the important values is because when we plug them in for x, they're going to give us the usual angles, pi over 2, pi, 3 pi over 2, and 2 pi that we usually evaluate the trig functions at. I'm going to show you real quick. So when I plug in 0, I get cosine of 0 over 3 plus 2. 0 over 3 is just 0. Cosine of 0 is 1. So I get 1 plus 2, which is 3. When I plug in 3 pi over 2, I get cosine of 1/3 times 3 pi over 2 plus 2. But 1/3 times 3 pi over 2, the 3's cancel, and I get cosine of pi over 2. Right? I'm getting that next quadrantal angle. And that's always what ends up happening. It's exactly how we pick these values. So cosine of pi over 2 is 0, 0 plus 2 is 2. And we could go on, I'll do one more. But you should already know what's going to happen. For x equal to the next value, which is 3 pi, you guys already know that the next quadrantal angle, well, 0, pi over 2, pi is the next one. And when I simplify this, I should get cosine of pi. And I do. I get cosine of 1/3 times 3 pi plus 2. And exactly the 3's cancel, which gives me cosine of pi plus 2. Cosine of pi is -1. -1 plus 2 is 1. So that's what's happening, right? The reason we are picking these important values is because when we simplify this expression, they end up being the usual 0, pi over 2, pi, 3 pi over 2, 2 pi. That's the whole kind of gist. Wow, it's already 2 o'clock. Let's do, so we're just gonna do some more examples because they do get a little bit wonkier depending on what kinds of coefficients we have here. So yeah. Let's see what else I want to say something. I do also intend to post a practice exam that we can go over on Thursday. Yeah. And the practice exam will look a lot like the actual exam. So let's look at this example. Let's graph y equal to, okay, 2 sine of 3 halves times x. Actually, I'm going to write this slightly differently just to make it so to think a little bit harder. We're writing a sine of 3x over 2 minus 1. So let's write down all the things. Amplitude is 2. The vertical shift is down 1 or -1. And the period is 2 pi divided by, what's the coefficient of x here? What am I multiplying by x inside the sine function?
3 over 2.
Exactly, 3 over 2. So it's 2 pi divided by 3 over 2, which is equal to 2 pi times 2 over 3. Or if you like, 2 pi over 1 times 2 over 3. 2 pi times 2 is 4 pi. 1 times 3 is 3. So my period length is going to be 4 pi over 3, or 0 to 4 pi over 3. And I don't know what the values are yet, but I know I'm going to cut this in half and then in half and half. Right? So I'm going to have 1, 2, 3, 4 equal length quadrants. This is always what's going to happen. It gets real old. It's the same thing over and over and over again. But it is 1, 2, 3, 4 equal length quadrants. And so how do I find this first point? Well, you could do it a number of ways. The way I'm going to do it is by dividing my period by 4. Right? Because if this is the whole period length, That's 1/4 of it. I can find it by dividing by 4. So 1/4 of my period is equal to 1/4 times 4 pi over 3. Here the numbers happen to be really nice. You can just say that the 4's cancel and get pi over 3, or you could write it out as 4 pi over 12 and then reduce that to pi over 3. So that's 1/4 of a period. So that, I guess, if 0 is the first important point, my second important point is going to be pi over 3. So my first point is, I used to have a better notation. How did I write this in my notes? Did I do anything smart in my notes? I did not. Oh yeah, I did. So I said that my first point, x sub 1 was 0. My second point, x sub 2 is 0 plus pi over 3, which I know feels silly to write, but whatever, pi over 3. And then my next point, I'm just going to keep adding this 1/4 of a period. So my next point is going to be pi over 3 plus another pi over 3, which is 2 pi over 3. My fourth point is going to be 2 pi over 3 plus another pi over 3, which is 3 pi over 3. I know that simplifies, but hold on. And then my fifth point is going to be the previous point, 3 pi over 3 plus another pi over 3, which is 4 pi over 3. I don't like to simplify any of these important points until the end, because usually you're going to have to keep adding something that's going to be easier if you don't simplify it. My cat seems to want out. I will open the door for her and see if she leaves. And so there's my important points. 0, pi over 3, 2 pi over 3, 3 pi over 3, which is pi, and 4 pi over 3. If you have a different way of finding them, that is also fine. This is just the way I have found to be the easiest. So then we do the usual graph. Let's see. So we're shifting down 1, so our new midline is -1. And then it's an amplitude of 2, so we should be able to go 1, 2 above that. -1 plus 2 is 1, and 1, 2 below, which is kind of close there. -1 minus 2 is -3. It's a sine one, so we're starting in the middle, and then we're going high, and then back to the middle at the next important point, and then the next important point down to the low, which is right there-ish. And then at the last one back to the middle. Sorry, my pen is super squeaky. Oof. So let me show you guys a mistake I've seen people make. I definitely see people go like, okay, middle, high, and then they want to go, bam, right there. That's not back to the middle, right? The middle is back down there. So be careful. You should only be trying to hit the x-axis if it happens to be the middle or the high or the low. If it's just some in-between thing, it's no good. So I'm going there, so. That's what it looks like. I will also remind you, I'm not going to pull it up, but Desmos is a great tool to check your work, right? I would say after you have graphed this on your own, it is worth looking at Desmos and being like, okay, did I do it right? I would really like to strongly encourage you, though, to try and do it on your own first before you look at some other graphing tool. Anything else I want to say there? No. I guess I do want to say, right? So again, each of these lengths here is 1/4 of a period. Yeah, and if I were to plug in each of these angles, if I were to plug in 0 here, 0 times 3 over 2 is 0. If I were to plug in pi over 3 times 3 over 2 is pi over 2. So each of these values, when they get put in for x, the angle actually becomes 0, pi over 2, pi, 3 pi over 2, 2, right? It's always the same 5 angles after you multiply them by this number. All right. How many more examples do I have? A few more. I think I might get through them all. We'll see. Let's look at this one. Yeah. I should say, one of the things I said before kind of makes a little bit less sense in the context of fractions. So before I said, like, when you have sine of 2x, your period is either 2x, 2 pi divided by 2, which is pi, or you can think about having 2 full periods in the length of 2 pi. It doesn't really make sense to say here you have 1/3 of a full period in the length of 2 pi. It is true, but the language just doesn't sound as right. Like, so from 0 to like 2 pi, which is right about there, I do have 1/3 of a full period, but again, that's not super helpful information. It's only really helpful if you have like a nice integer coefficient of x. Okay, a couple more examples and then we'll be done. Let's try this one. Yeah. Let's try y equal to -2 times cosine of 4x over 3. Not plus 1. Yeah, fine. Okay. Plus 1. Okay, sure. Same stuff. So we have an amplitude of 2, a vertical shift of +1, and we also have a vertical flip, right? That negative there is what corresponds. If you have a negative leading coefficient like that, it's multiplying your trig function, it's going to flip it over. So usually cosine would be high, middle, low, middle, high. We're going to flip that whole thing over and go low, middle, high, middle, low. And then we have the different period. So let me show you a slightly different way of going about doing this. We know this is going to have this usual trig look, right? All these trig functions look kind of the same. I mean, just essential. So for this one, the screen pen is starting to go. I got a new green pen over here. Okay. How about that? Notice I haven't found my period stuff yet, because I want to show you that you don't really have to find the period until the end if you don't want to. So I know this one's going to have a midline of +1. So my vertical shift is y equal to 1. And then I know I'm going to be going 2 above to 3 and 2 below to -1. And I'm going to have a vertical flip, which means I'm not starting high, I'm starting low. And then I'm just going to say my period ends there. And then I'm going to cut it in half, and each of those in half. So I'm going to go low, middle, high, middle, low. I've drawn better graphs, but you know. So there's what this looks like. There's my flipped cosine function that shifted up 1, has amplitude 2. The period I'm going to fill in now. So the period, come on, board. So the period is going to be 2 pi divided by the coefficient 4/3, which is the same as 2 pi times 3 over 4, which is 6 pi over 4, which reduces to 3 pi over 2. So the end of my one period here, that's going to be 3 pi over 2. Now, here's the thing about doing it the way I've done it. Your x and your y might not have the same scale, which is fine. 3 pi over 2 is like 4.5. That's 4.5. That's 3. I don't know. They're close to being the right scale. It doesn't matter. Your scale on the x and the y could be totally different. It's totally fine. But I do need to find those other points. So I'm going to do the same thing I did before. I'm going to take 1/4 of my period, which is 1/4 of 3 pi over 2, or 1/4 times 3 pi over 2, and get 1 times 3 pi over 4 times 2, which is 3 pi over 8. My first point is at 0. My next point is this much further, so it's 3 pi over 8. My next point, I'm going to add another 3 pi over 8. In fact, let me show you. Okay, so to get from here to there, I added 3 pi over 8. To get from here to the next one, I'm going to add 3 pi over 8. 3 pi over 8 plus 3 pi over 8 is 6 pi over 8. Yes, I know it reduces. No, I do not want to reduce it. I also don't want you to reduce it unless you really want to, right? You can leave these x points unreduced if you prefer. I certainly prefer to, because then the next one, I'm going to add 3 pi over 8, and 6 pi over 8 plus 3 pi over 8 is easy to add. It's just 9 pi over 8. And then finally, we do it one more time just to check. If I add 3 pi over 8 again, 9 pi over 8 plus 3 pi over 8 is 12 pi over 8. And 12 pi over 8 definitely reduces to 3 pi over 2. So I'll reiterate for the, I don't know how many time. I don't care how you get these values for the x values. I just care that you are able to get them. They should all be equally spaced out apart. They should all be a quarter of a period long. I prefer doing it this way, where you start at 0 and then you just keep adding 1/4 of a period 4 times. Okay. Yeah, we got time for one more example. Sure. All right. Probably the last example. Yeah. I shouldn't try and squeeze in 2 more examples. Let's do this one. Y equal to another negative, so -2 sine of x over 4 plus 2. No, they're all pluses. Am I biased to a plus? No, those lines. Okay. So again, like I said, these start to get kind of repetitive or old, like me, if you will. But it's still the same stuff, right? So we're going to find the amplitude. The amplitude is +2. We have a vertical shift of +2, and we have a vertical flip because of the negative sign. And then we have a different period. Our period here is 2 pi divided by what?
1/4.
Thank you, yes. Dividing by 1/4 is the same as multiplying by 4/1. 2 pi times 4 is just 8 pi. So you might have noticed that when I draw these, my one period is typically about the same length, regardless of if it's 8 pi or if it's 3 pi over 2, right? Those are very different numbers. 3 pi over 2 is like 4.5. 8 pi is like 25. So what I want to emphasize here is that it's okay to draw your x and your y scale differently. I do it all the time because it's convenient. Right? But if this is, if I was going to try and draw it to scale, if that's 8 pi, then like that's going to be 1. And that's going to be hard to draw so that the reader can see what I'm trying to draw. So I'm not going to do that. I'm going to make it so that my y scale is a little more normal. Let's see. Oh, might need a little more room here. So my new middle line, or my vertical shift, is y equals 2. And I have to be able to go 2 below down to 0, and 2 above up to 4. And now, again, I don't have to find the x values until the end if I don't want to. Sometimes it's nice just to do the period and draw the thing. So I do know I have to cut it in half, and then each of those in half. Now I will point out, this one you could totally find the x values easily, right? It's easy to cut 8 pi in half, and then find the midpoint of each of those. I'm still going to do it the other way, but I want to point out that if you can see the math easily, just do it the easy way. So sine is going to start in the middle, and then usually sine would go high, but since it's a flip, it's going to go low. So we go middle, low, back to the middle, then high, then back to the middle. And I feel like this length is not quite the same as that length, but you know what? It doesn't have to be perfect. So that's how it would look, right? A flipped over sine function. And then we find the important x points. I'm going to find it by finding 1/4 of my period. So 1/4 of my period is 1/4 times my period, which is 8 pi. 1/4 of 8 pi is just 8 pi divided by 4, which is 2 pi. So this first point is 0. And then we add 2 pi to get 2 pi. We add 2 pi to get 4 pi. We add 2 pi to get 6 pi. And we add 2 pi to get 8 pi. But this one, I think you could have easily said half of 8 pi is 4 pi. Half of 4 pi is 2 pi. And then between 4 pi and 8 pi, the middle is 6 pi, right? This one is pretty easy to just kind of see those values. So that's a complete graph for this one. Do I want to say the thing? Yeah, I really do want to say the thing. So again, I want to emphasize the fact that these are the x values because when we plug them in, they give us the angles that we want. I will mention, sorry, I just got an alert from PG&E that there might be outages between 3 and 10. So we're going to have office hours today from 2:30 to 3:30, but if my power goes out, office hours are canceled. So if you try to show up for office hours and I'm not there, it's because my power is out. I don't think that's going to happen, but you never know. Anyway, what I wanted to say is, right, if my angle, or sorry, if my x value is x equal to 0, I'm getting sine of 0/4, which is sine of 0. I know there's more to it, right? I know it's -2 times sine, but I'm just really care about showing you that the angle is the same angle as usual. If I were to plug in x equal to 2 pi, well, if I plug that in here, I get sine of 2 pi over 4, which is sine of pi over 2. If I were to do 4 pi, right, I would have sine of 4 pi over 4, which is just sine of pi. If I were to do 6 pi, sine of 6 pi over 4, that reduces to sine of 3 pi over 2. And then if I plugged in 8 pi over 4 is 2 pi. So the reason these are the x values we want is because when we plug them in, they give us the usual quadrantal angles, pi over 2, pi, 3 pi over 2, and 2 pi, and 0. So I know I've said that like 5 times already, but I want to say it one more time. That's kind of the thing. There is one example we didn't get to. If you're looking for extra practice, I encourage you to try it on your own and then look at the notes I've already posted, I think, on Canvas. So the last example that we didn't get to was y equal to 3 sine of 3x over 4 minus 2. If you're looking for some extra practice where you can see the solutions written out for you, I would say try doing that one on your own and then look at the notes that are posted in module I think. Let me double check. In class I, or module I. Wasn't scared, look at that, good for me. So yeah, if you're looking for another example, try graphing this one on your own and then look at the notes, the class I notes and examples I actually used in class to see this on the last page if you want.